Hello and welcome to another screencast episode of Three Devs and a Maybe. My name's Ed Mann, and today we're again joined by Joe Watkins. How you doing, Joe?
Good. Hi, everyone.
We haven't done one of these since probably last year, actually, and they turned out really well. People had some really good feedback on them, so it's great to kind of have another screencast going, and hopefully, fingers crossed, this is going to be the only cut we need to do of this. We've got the audio set up, we've got the video set up, we've got everything recording, and we've checked that it's been recording, so yeah, fingers crossed we're going to be fine. But yeah, so yesterday on Twitter, you sent out a poll, and you got some really good traction, and you just kind of messaged me saying, "Oh look, I've got an idea for a screencast. Are you up for recording it?" I was like, "Hell yeah!" So I'm just wondering for the audience, what we mind just explaining what the actual screencast is going to be on?
Okay, last one we done was about writing PHP extensions. And so I thought we'd do one about modifying PHP, like adding features, like of the kind of patches you need to write for RFCs.
That's very cool. So yeah, as you say, so like we went through PHP. It was predominantly PHP 7 stuff which you did, wasn't it? Where we actually set up PHP 7 extension environment, made a simple extension, and then we actually expanded on that extension with it was a dynamic array, I think it was, that we used, dynamic vector. So yeah, so this time we're going to go even more in depth. So yeah, lead the way, man. How are we going to go start doing this?
We're going to just implement a new expression. It's like a special case function call.
Okay.
Just so that you get to know the different bits of what's involved and what needs changing and why, sort of thing. And it really doesn't do anything. It copies the parameter to the return if it's a string, or else it throws an exception. So it doesn't do anything useful. It's not a thing you can RFC tomorrow. But
you're going to see a couple of these RFCs out when we release this. You'll be like, I remember this from an example video.
No, it really isn't. It really isn't useful. But maybe later on we could do another screencast of the same type, but one that depends on you having watched this one.
Yeah, absolutely. That sounds great. I mean, as you say, so the example you're going to give, the contrived example, is going to allow you to explore all the different areas that you're going to need to know about if you're going to do something like this in the future.
Yeah, but it's not actually useful. But you could easily turn it into something useful. It gives you everything you need to know to write something useful. The place we're starting at is we've got PHP installed, PHP 7 installed. We've got the source code in user source, which can be cloned from GitHub or git.php.net. And the first thing to do is the Lexer, because the stages of compilation, right, taking your text, your code in a file and turning it into executable code for Zend, Lexing's the process of turning the characters in the file into a stream of tokens. And tokens are like if and keywords and things like that, and braces and things like that. These are all tokens that the language handles and knows what to do with. And so the Lexer turns it into a stream of tokens, and the parser takes the stream of tokens and creates, nowadays, an abstract syntax tree from the stream of tokens. And then the compiler takes the abstract syntax tree and compiles it into the executable code for Zend. So it starts at the Lexer. So if you're adding a new control structure or keyword or whatever, new language feature, basically, you need to Lex it first. The language scanner is named Zend language scanner.l. It's in the Zend folder. It's just open in a random place. So .l is a really strange extension, and the parser's got a .y extension.
Yeah, I was just wondering about that. A little different.
Yeah. These are actually input for parser generators and Lexer generator. So that's why they've got strange file endings. The files that are actually used in your code are C and header files, but they're generated from this. So you edit this. Most of this is pretty boring, so you can ignore it more or less. What we're doing is we're adding a new expression. So just find anything that feels familiar. While you don't know your way around this file, all you've got to know is that all these are keywords, and then they return the identifier token. Yeah. So you can basically just copy that We're calling it hipster, by the way. So this allows the Lexer to turn hipster into the token T hipster. And that will get fed into the parser. Now,
So adding it into here now will make that a valid token to be in any PHP script.
yeah, but I mean, it'll. If you tried to rebuild PHP now and you put hipster in some code, it would just say unexpected.
Yeah.
It would just know that the name.
Not valid in that context of when you're using it.
But it wouldn't be expecting it, so it wouldn't. It would only generate errors. So the next thing to do is the parser. Now, this is extremely confusing.
Oh, wow. Okay.
Now, it does seem a bit... If you're used to parser generators, then this is normal, but it's not standard C, and it's kind of weird notation and format. The thing to know is, because we're adding the hipster keyword or operator, whatever we call it, it's non-associative. So the first thing to do up here is that. Now, associativity is like a subject all by itself.
Yeah.
So I'm not going to try and explain that here. Okay. Now that's associativity, and here, all these token things, you can see it's the name of the token, like T shift left, and then this is like the text description of it.
Yep.
So that when you see errors, it says like unexpected shift left and then TSL. So it's for humans. So you just need to put your token in here. I mean, pick a sensible place for it. I'm not going to do that right now.
Yeah, because you're a hipster, man. So being a hipster, you need to...
But pick a sensible place for it. Right, and then we're adding a new expression now. So below all this, what we can consider boilerplate, it basically is. We've got these rules. Now, again, if you're used to parser generators, these are basically standard form. Again, it's a huge subject, so you need to... I mean, you can read up about it, or you can do what most people do and work it out from trying.
Yeah, for trial and error.
Yeah. There is some good articles on it. I'll collect a few up and we'll stick them in the show notes before we publish this. Just searching for the block where we need to... Now, you'll notice that these aren't terribly well named. I mean, this is called expr without variable, and within in the second rule is the word variable, so I don't know in what sense that means it's without a variable. But this is what we're adding, an expression. So you can see here, this is basically the rules for all the binary and unary and cast, yields, prints, and things like that. So again, you've got to choose a sensible place. Not only because if you don't, it just won't work. You'll have conflicts and weird stuff will happen. So you've got to really carefully choose where you put your new rules. In this case, it's quite simple. It's just one line like that. So we're gonna accept hipster and then an expression in brackets and create the abstract syntax for that. Now, this means the return value, the double dollar sign, and the numbers start at 1. So this is 1, and this is 2, this character on its own here, and this is 3. So the abstract syntax for the expression is number 3. Okay, so the AST we're creating is a node named hipster with that one child, the expression.
Well, would it be okay to see how you kind of plan to use hipster in kind of a PHP high level?
is an expression. So like that.
Right. Yep.
Okay. So it's just like a special case function call. It looks like a function call, but lots of stuff does look like that, like include and require.
Yep.
They're not function calls; they're language constructs. Okay. So yeah, that's the weird numbering.
Positional numbering based on like where it starts as opposed to where you think it would be, which is start with that expression.
And like each character is a thing as well. Normally you don't use them, but that's why that's not the second. What looks like the second thing. That's why it says 3. Yeah. So that's that now. So now the parser understands it, and it's going to create some AST now.
So is there a certain parser, like, so the parser.y file is the high level kind of, this is declaring how the parser should be. And then is there a specific parser that PHP actually uses then that actually generates the parser itself?
Bison or Yak.
Bison, okay.
Okay, yeah, that's pretty standard, yeah. The two are like interchangeable on some systems. They're like aliased and symlinked and stuff like that, so you never really know what you're getting. But I think there might be a requirement above some version at the moment, but it's pretty much ubiquitous, so it's not a problem. That is one of them things where I remember a few years ago talk of we couldn't use this thing from Bison because nobody was using that version yet. But now that doesn't really happen. I mean, everyone keeps their operating systems up to date, really. So we get to use pretty recent stuff. Now, again, defining what an abstract syntax tree is probably outside a full explanation is outside of the realm of a podcast, but basically it's as it sounds. It's like an intermediate representation between the text that you've written and the code for Zend, and it's an abstract syntax tree. It's literally that.
So it's where it's been from the text, been tokenized, lexed essentially, and
then passed into the abstract syntax tree,
which abides by all the rules and stuff to put it into the tree of what the lexer's been told, like how it's structured, etc.
The parser, yeah. Is generated from your rules in the parser. And it should. The thing to remember is when you're adding new stuff is imagine how the abstract syntax will look before you try and add stuff, because what it will look like and where you can have it in the tree defines where it goes in the parser.
Okay.
And what the rules look like, because that's how it works. So we've done it, we're like hacking here, but when you know what all this stuff is, and I'm not just showing you, when you know, what you do first is think about what's the syntax tree going to look like, and then that puts you on the right path. So obviously we're not doing that here because it's not a very complex thing, and I'm showing you.
Yeah, showing us around kind of how.
Yeah, it's just like a brief tour, so you can see that it's not voodoo or anything. It's not particularly involved. I mean, everything you need to know is literally written in the files that you're changing. People do complain that there's no documentation for internals, and that's true, there's not. But it is commented quite well, and most of it is as you would expect once you've started reading, sort of thing. It follows a kind of weird logic, which sometimes breaks. But you can sort of find your way around once you actually start looking. It's just having the reason and courage to start looking in the first place. Most people don't get past that. Abstract syntax trees all work differently. There's no point in me saying this is what an abstract syntax tree is. This is what an abstract syntax tree is. This is what Zen's abstract syntax tree works like. It's a little bit weird if you ask me, but it's probably about as efficient as it could have been. So anyway, you'll notice this is just an enum, which is a list of constants, basically. This magic here, it's used to set how many children are expected for a node, or if it's a list. So again, reading through this can tell you just about everything you need to know. I'm just going to find the bit we need to put in.
Well, one thing I was going to ask actually in this case, so you said that include and require are, essentially language constructs, and also print is. So print is a language construct. It isn't a function that has kind of got a higher priority in some regard that, it gets converted into the function call. It is a language construct.
Yeah, it is a language construct. Right. Yeah, it's echo.
So it's echo under the hood, essentially.
Yeah, like die and exit are basically the same thing with slightly different behaviour, but they're
because I can see like shell exec as well there, and things
so
like
is,
that.
So is strlen, and there's probably some other ones. But yeah, some things are special case because it would be like strlen is extremely high frequency, and if it really it did cost a function call every time you wanted to check the length of the string, that would just kill everything, because it used to though, but it's special case now, so that's nice. You can see here they're grouped into the number of child nodes that each thing is expecting. We're only expecting one, which is the expression. So put it at the end of the suitable group.
Yep. Hey, hipster.
Yeah, that's all that's needed in there. That's all that's needed, but people will shout at you. Because in here, there's logic for dumping the AST.
Right, yes. I'm sure they're wanting to know that this actually exists.
Yeah. So you should do that, and you can, it's pretty...
So the AST is actually new, isn't it, in PHP 7?
Yeah, it is. PHP 5 doesn't have an abstract syntax tree. It just it generated code as it was parsing it.
So you couldn't do any pre-optimizations or anything like that?
No, but it's worth saying that we don't do that now, because we could, but we don't. Optimization is still done after compilation by opcache. So we're not really using it to its full potential, but it's early days.
Yeah, it's good to have it in there.
Yeah,
and you can see here where you've got the string. So yeah, essentially this is an if block, and it's just saying else if, and it's just building up a string representation.
Yeah, so you basically have to write that for your control structure or whatever, and you'll be able to search around and find out how that works. So I'm not gonna show you that today. I've got notes here, and I've just put skip boring. So
you're doing us a favour then, eh?
Yeah. So now we've got the tokens understood. It's passed into our abstract syntax, and we know what our syntax is going to look like.
So at this time, if you were to run this and put hipster in, would it complain still because it doesn't know what to do with that?
Yeah, it would. It would fail at what we're doing now, which is the compile step. I'm just putting this in an arbitrary place.
Yep.
Haven't thought about it at all. It needs to be in here. Put it in a sensible place, but I'm not.
Because we're hipsters. There we go.
Yeah, we're hipsters. We can do whatever we want. Okay, we can see this is a pretty standard form compile function. I'll show you in a minute. There's a big switch where they're all called for all the different kinds of AST. So this will be called when the kind is Zend AST hipster.
Yep.
And we know that the expression is the first and only child.
Only child of it.
Yeah. We compile the expression. Now,
so compiling the expression means letting it deal with what it needs to do within that.
It might be a string, or it might be a function call.
It could be recursive, whatever it needs to be. It could just do what it needs to do, recur down.
And it's abstract syntax, so we know it's an expression, so we know it will compile to an expression. Yep. So the node is what's used by the compiler, whereas this AST is used by the parser sort of thing. So we're basically changing the sort of format of it, kind of. And then we emit our new opcode, which is Zend hipster, and you see the first parameter as a result, then the opcode, then op1 and op2, which is every opcode's got like a maximum of 2 operands. op1 and op2. We're not using op2, so just null. That's all that's required for our thing. Obviously, it gets much more complicated than that. If we just look at,
yeah, I was just having a look at the ones above that. You can see a lot more.
You can see it. You can see it does get complicated, but this is something you have to read, and understanding it relies on your understanding of the AST and a few things before it. So dive in. I'm keeping it extremely simple in the hope that
people will have a look, and as you say, this is a good jumping off point to say, look into how these constructs work and how they are processed.
What's actually involved is not complicated, and even quite advanced features is not really difficult C to write, and it's not. You don't need to be a master of the art to be useful.
It's just where to look and to understand what bits.
A lot of people have done C before, so if you know it at all, and even if you don't, you recognise a lot of the syntax because it's just code and it's just normal code. This is what code looks like in nearly any language.
Yeah, but it all C-looking languages, which you're bound to touch on, even PHP.
Yeah, everyone knows one. Everyone knows one. Like I said about Visual Basic earlier, but no one really writes in languages that look weird, do they? I don't think they do. People that write in Ruby and Python are going to hate me, but I don't think it's. It always feels jarring to read code without braces and that needs to be indented in a particular way.
So not a fan of the Lisp dialects then.
I find that really weird. I don't like it to be a challenge to read it. It's difficult enough when it's a challenge to understand it. You don't actually want it to be effort to just read it.
Yeah, you don't want both.
Yeah. So that's going to be our compile routine. I just find a place where the big switch is.
Yep.
Again, this is an arbitrary. This is pretty arbitrary.
There we go. This is the one.
I haven't paid any attention. Yeah. This is the compiles the expression nodes. So somewhere in here, because that's what we're creating an expression. Somewhere in here, add your. I put it in there in. Oh, this code's on GitHub, by the way. So if you wanted to.
Oh, brilliant.
If you wanted to leave for it, yeah.
I'll put it in the show notes.
Yeah,
for sure.
Okay, and that will result in the generation of our new opcode. Now, Zen hipster is what we called it. So now, this file, ZendVMDef, is a huge file, and it's used as input to generate the real VM functions. So they've got a pretty strange format, and you can't really. If you move this bracket here to here, you break everything. So.
Wow. Okay. So very fragile.
Yeah, I only just found out that today. I've never really done it in a rush before.
So from here, so we've got the Lexer, then we parse it.
Yeah, and then the parser creates the abstract syntax,
which is then what we do. We then compile that
to executable opcodes.
Right, awesome.
So our new opcode's got one operand, which is the expression, and it's called Zen hipster. Like I said, these handlers have got a pretty standard form, and you don't try to deviate it from it unnecessarily. The things to know are, this is the opcode number, the first one, that number there. Just look at the last opcode handler that was installed, which was 183, so use the next one, which is 184.
So it has a unique identifier for that opcode.
Yeah. Then the name of it. Then these are the types of op1 and op2. Now, the type can be, see that, CV, constant. They can be compiler variable, temp, or var, or any. So we're going to support any because we don't care what kind of variable we get because we're not doing anything interesting with it. So we can just put any there. Now, this is basically, a lot of this is boilerplate. On some platforms, this, use upline, save upline. On some platforms, it doesn't even do anything. But because the VM supports being generated in different ways and also built on different platforms where different things are required, you've got to copy the boilerplate. So you get to know, like, based on what kind of handler you're writing, you get to know what it should kind of look like.
Yep.
It's basically normal code. But one thing that you might not see, you won't basically see in extension code is this unexpected and expected thing.
Okay.
This is like a branch optimization thing. So if you're writing a branch that you expect is going to be travelled a lot of the time, you write if expected and then your condition inside parentheses. And if you don't think it's going to be travelled all the time, you write unexpected. This is so that the compiler can, not the Zen compiler, but the actual compiler that builds PHP can optimize the code to put hot paths in the right place.
Right. So it's aiding that step.
Yeah.
So just giving them so it may not take advantage of it, but you hope it does. Yeah.
Yeah, but do it if you've got that information up front and use it. And the other thing, I put this exception in here rather pointlessly, really. It just says here if the operand we get is not a string, throw an exception saying hipster expects a string. Now, I only did that to show that when we'd done extensions and we touched on throwing exceptions, it was you just had to execute the throw exception function.
Yeah, and that would deal with it.
Inside the VM, we got to instruct the VM to handle that exception straight away.
Right.
So that's why I did that. And then this just says copy the operand to the result variable, and that's what it does. If it's a string, you'll get a copy of it. That's all the hipster thing does. That's basically all there is to say about that. It's worth digging into these and finding one that's really quite similar to what you're doing, and seeing how it works, and also having a look at the definitions of what you remember lxr.php.net.
Yeah.
Search the definitions of these, and you can see for yourself how things change and why it's important to sort of use the standard form, even though on your operating system it might not actually be used. It might not even generate any code.
But you have to deal with the base case of if it was.
Yeah. You have to deal with all cases. So yeah, that's the thing to do. And reading through this VM definition file tells you how all kinds of things work, like assert there, and how it jumps around things, like when assertions are disabled, it jumps around it, and like how if works and while and things like that. And that's how you really get to understand it. I mean, I can show you where it is today, but I mean, I can't explain it all, every little bit. Hopefully just give you enough of a...
I think that's it, yeah. It's giving enough kind of insight into these are the areas that you want to look into.
Yeah, that's basically all the actual requirements for our thing. Now, because we just changed that VM definition file, we have to generate the VM code again, and that's how you do that. Zen-vmgen.php.
So what is that? Is that a file you've made, or is that...
No.
That's actually inside. That's interesting.
Yeah, that's distributed with PHP, yeah. Oh yeah, PHP uses PHP.
I know, that's very meta.
Yeah. Hopefully that should work. It could be quite slow.
So this is now all the stuff that we've just done. We're now recompiling PHP with those additions.
Yeah, with those additions.
And that's all that we need now for that hipster
for that
language
that
construct.
silly, useless thing to work. Now, obviously, this is not all that's required for an RFC. You need tests and you need discussion mostly. But it gives you a good idea that actually to just get started, it won't take very much effort for most.
And as you say, like if you've got the code, you've got something that people can talk about on the RFC, and then bring discussion.
And people will criticise it as well, because you'll probably do it wrong. Like, even I do it wrong when I do patches for stuff.
But it's a good starting off point, because you've actually got something to be wrong about, as opposed to nothing.
Yeah. So...
Here we go. So we're going to make up a hipster example. We can pretend now, with the beauty of editing, that this worked first time.
Yeah, this is first time, people.
First time, people. No chance that this will work a couple of times in. And let's see. Well, hey. So this is essentially then the hipster. So being a hipster, this is actually like the identity function for strings, that you pass in a string and it will just return that string.
Yeah, basically.
And that's awesome. And actually, that was really interesting when we were doing possibly some debugging. There was no chance of that, but you showed us, the PHP debug, and you showed the opcodes. Is it all right if you just show that? Because that looked really interesting.
Yeah.
Because that was really cool, like being able to see like how the actual. So this is like the built-up representation. This is what the VM, I suppose, sees. And there we go. There it is. There's our new opcode.
A bit of a mess, the output there, but that is our new opcode. Yeah.
And you can see, as you say, like the input to it, and then what's actually happening, and echoing and returning that. That's great, man.
Yeah, that's all there is to, doing the bare minimum for
something like an RSC feature, like a new language construct. That's awesome. Well, thanks so much, Joe. I think the audience are really going to enjoy that, and it's really good to kind of, I'd say, get your experiences and your expertise on this, and kind of you showing it to us, because it can be a daunting task, I'm sure, and I know personally, to look through these files and stuff. But if you get an idea of where things are and you get to play around with it, I think that's the best way.
That's all you've got to do, is just have the courage to actually look and have a go.
Brilliant.
And even if you get stuck, there's loads of people around that will help.
Well, that's it, exactly. And very friendly people, like yourself, who's sure if someone's got a really good idea, an idea that they want to, kind of explore, and if they're trying their best with it and they, get stuck, I'm sure you don't mind them pinging you on Twitter, or I may have just.
No, yeah, that's fine. Yeah.
Awesome. Well, audience, I think that's been another great screencast. Really interesting one, and yeah, we'll speak to you next week, and hopefully you'll see us in a new screencast soon. Goodbye, audience.
Bye.